Alrighty, so for these ones, we have a force that's being 21 up, force of a, there. A force of 21 newtons is applied parallel to the motion. So therefore, the work done to it, our equation for work is just going to be equal to force times displacement. So that's just going to be 21 times 4, and that's going to get us our 84 joules. Acceleration, we have a force. Force is equal to mass times acceleration, so we can just say force is equal to ma. A is going to be equal to our force divided by our mass, which is then going to give us our 21 divided by 3, which will get us our 7 meters per second squared. Our next one, our final velocity, c. We've got to figure out, well, it starts at rest, so therefore our final velocity is just going to be all of our energy converted into, all of our work done converted into kinetic energy, because we're making the assumption that it's parallel to its, it's not moving up or down, so there's no potential energy. So we're going to say that the work is equal to our kinetic energy. So that means that this is going to be equal to our half mv squared. So that means that our v is going to be equal to 2 times our work divided by our mass, square root of that, which would then be equal to the square root of 2 times 84 divided by 3, and that should be equal to our 7.5 meters per second. I am working with some rounded numbers here, but that's okay. The average power, so for D, power is equal to our work divided by time. This is going to be our 84 joule. Oh, no, I've got done that wrong. I have not done the time taken. So for D, the time taken, well, we have a final velocity, we also have an initial velocity, we have an acceleration, so therefore we can find time by v is equal to u plus at. Our u is equal to 0, so our t is then going to be equal to v over a, which is going to get us the 7.5 divided by 7, which is then going to equal our 1.1 seconds being rounded. Finally, for E, we're going to calculate the amount of power. So the power for this situation is going to be power is equal to work divided by time. Our work is 84 joules divided by the time taken to do that, which is the 1.1 seconds, which is then going to get us the 76.4 watts worth of energy. The final kinetic energy, this is interesting mainly because for final kinetic energy, if we plotted in our, or plugged in our 7.5 meters per second, so we go kinetic energy final is going to be equal to a half mv squared. This would be a half times 3 times the 7.5 squared. That actually comes out as being 84.4 joules. Now, the interesting thing is that if you get more kinetic energy out of the system than you actually put into it, there's something gone wrong. So this is why our kinetic energy final must be equal to the work applied. Therefore, we've only applied 84 joules worth of energy, so therefore our kinetic energy final is also going to be 84 joules.